I'm sharing my screen. Yes, my screen is visible, no? Yes.
Yes, sir.
Okay. Okay. Yes. Okay. So here I'll start the encoders. Okay, what are these encoders, and we'll discuss about the priority encoders. Okay, what are these priority encoders? Okay, so we'll discuss. Okay, first encoders. Okay, encoders. Okay, so encoders have what? Encoders have how many inputs? 2 power n inputs. Okay, and n outputs. 2 power n inputs and n outputs. Okay, so what it will do, it will produce the binary equivalent. Okay, produce the binary equivalent of input. Okay, binary equivalent of input. Okay, okay, equivalent of input. Okay, and next, so there are some ambiguities in encoders. What are these ambiguities? Okay, or we can call as some limitations or disadvantages. Okay, so when all outputs are equal to 0. Okay, when all outputs are equal to 0, okay, we can't find out which input is selected. Okay, so when all output are equal to 0, then this is one ambiguity. When all outputs are equal to 0, and if more than one input is active high, one input is active high. Okay, more than one input is active high. Okay, then the encoder may produce wrong output. Encoder may produce wrong output. Okay, wrong output. Okay, these are some ambiguities for encoder. Okay, so if you see the block diagram for encoder, so the encoder will look like this. Okay, one second. Yes. Okay. Yes, encoder. So diagram. So like it will look like this. So here you have 2 power n inputs. Okay, 2 power n data inputs. Okay, and this is enable pin, and you have n data outputs. Data outputs. Okay, so here 2 power n is to n encoders. Okay, so this is the block diagram for what encoder. Okay, basic encoder. So here if you see the 4 cross 2 encoder. So what is this 4 cross 2 encoder? So 4 cross 2 encoder, so here it have how many inputs? 4 cross 2 encoder, 4 cross 2 encoder. So it have four inputs. Okay, let the inputs be y3, y2, y1 and y0, and two outputs are let us take a1 and a0. Okay, so here I am writing the outputs y3, y2, y1 and y0, and what are the outputs? Two outputs a1 and a0. Okay, so here at a time any one of the input is 1. At a time any one of the input is 1. Okay, so this y0 is 1 means what? So we already seen previously, it will produce the binary equivalent of input which is active high. Okay, it will produce the binary equivalent of output which is active high. Okay, so here it will produce the binary equivalent of input which is active high. Okay, so which is active high means here which one is active high? So if you see which one is active high, y0 is active high, no? So y0 is active 5 means what is the binary equivalent of y0? 0 0 you'll get. Okay. Similarly 0 0 1 0. So you are getting 0 1. And next 0 1 0 0. What you are getting? 1 0 you are getting. Okay. y2 is 1 and 1 0 0 0. Okay. y3. So 1 1 will be 1. Okay, so like this you will get the binary equivalent. And here if you want to get the logic expression, what are ones here, this a1 equal to what I can write, so a1 equal to I can write as a1 equal to y3 plus, so here y3 is 1 and y2 is 1, so y3 plus y2 I can write. Okay, and next a0 equal to what, so a0 equal to, here a0 equal to, so this one, if you see this one, okay, this one and this one, so I can write y3 plus y1, y3 or y1, y3 or y1. Okay, so I can draw the logic diagram. So y3 and y2, this is connected with which gate? OR gate. OR gate, and here you are getting a1 equal to what? Y3 plus y2, and this is y3 and y2. Okay, and next so y3 you are taking as one input, and one more input is y1. Okay, so y1, and it is giving so a0 equal to what? y3 plus y1. Okay, so like this you'll get the 4 to 2 encoder. Okay, 4 to 2 encoder. So if it is octal to binary encoder, I think you can design, no, octal to binary encoder. So octal to binary encoder means, so how many inputs are there? Octal to binary encoder. So here if you see octal to binary encoder, octal to binary encoder. So octal to binary encoder. So you have how many inputs? Total 8 inputs are there. Okay, 8 inputs are there. What are these inputs? Let us take y7 to y0. These are the 8 inputs, and 3 outputs will be there. 3 outputs, those are a2 to a0. Okay, so so you need to write, so y7, y0, y1, one second, y6, y5, y4, y3, y2, y1 and y0. Okay, and next here you have a2, a1 and a0. Okay, so at a time any one of the input is 1, so that means here y0 is 1. Okay, remaining all are zeros. Okay, here you are getting the binary equivalent, that is what? 0 0 0. Okay, and next this one is 1 and remaining all are zeros. Okay, remaining all are zeros. This binary equivalent you will get. Okay, and here y2 becomes 1. Okay, this binary equivalent you will get. Okay, and next y3 becomes 1. This binary, remaining all are zeros only. Y3 and y4 becomes 1, so you will get the binary equivalent 1 0 0, and y5 becomes 1, and you will get the 1 0 1, and y6 becomes 1 1 1 0, and y7 becomes 1. Here you are getting 1 1 1. Okay, 1 1 1. So if you write for equation for a2, so a2 equal to what are ones are there? So a2 equal to, you will get y7 plus y6 plus y5 plus y4 you will get. Okay, and next a1 equal to y7 plus y6. Okay, these two, y7 plus y6 plus y3 plus y2. y3 plus y2 will get. Okay, a0 equal to y7 plus y5 plus y3, odd numbers. Okay, y3 plus y1. Okay, so with this equation I think you can draw the logic diagram. Okay, so this is nothing but what? Octal to binary encoder. Okay, octal to binary encoder. And next we'll see the priority encoder. What is this priority encoder? We'll see. Okay, so priority encoder. So priority encoder, so whatever the ambiguities are there, that we can avoid, we can overcome in the priority encoder. Okay, priority encoder. So priority encoder, you have like so here in this priority encoder, the output, so in this encoder output corresponds to active high. Okay, output will be active high, which is having highest priority, highest priority. Okay, so that means suppose four inputs are there, y3, y2, y1 and y0. Okay, so y3 is having highest priority and y2 is having highest priority, next y1 is having highest priority, y0 is having highest priority. So that means suppose two inputs are 1, suppose y3 and y1 both inputs are 1, means this is having highest priority, means it will give this output, it will give this output. Okay, like that. Suppose this y2 and y0 both are 1, so based on this priority level, this is having priority or highest priority, it will give this output. Okay, so so like this we can get the priority level, and again it will check for the condition, that means output that is v. Okay, this will check whether the code is code is available is valid or not. Okay, code available, okay, code available is valid or not, valid or not. Okay, we are seeing the two ambiguities in the encoder, no? So what are the ambiguities, what are the disadvantages we seen? So here two ambiguities are there, those are when all outputs are equal to 0. So this we can overcome by applying this output v, this is valid output or not. Always it will check for whether the outputs are valid or not. And next here depending on the priority level, I will give this one of the input is active high, so here it will produce the wrong output, but here based on the priority level only it will give the output. Okay, so here if you see the block diagram, so how the block diagram will look like. So let us take 2 power n cross n encoder, 2 power n is to n priority encoder, priority encoder. Okay, so this is priority encoder. So you have how many inputs? Let us take 2 power n inputs. How many outputs? N outputs. Okay, these are n outputs. Okay, n outputs. So here there is an enable input. Okay, and there is a valid output will be there. Okay, valid output will be there. Okay, so here I want to see related to this priority encoder, 4 to 2 priority encoder. Okay, 4 to 2 priority encoder. So how to find out this 4 to 2 priority encoder? 4 to 2 priority encoder. Okay, if you see the 4 to 2 priority encoder, so if you see the block diagram, so this is the block diagram, 4 to 2 priority encoder. Okay, so here 4 inputs are there, y3, y2, y1 and y0, and 2 outputs are there, a1 and a0, and one valid output will be there, that is v. Okay, so y3 is having the highest priority. Okay, and y0 is having the lowest priority. Y0 is having the lowest priority. Okay, so here how many inputs are there? You have 4 inputs. Okay, and how many outputs are there? 3 outputs along with the valid output. Okay, so y3 is having which priority? Highest priority. Okay, and y1 y0 is having the lowest priority, okay, so I can draw the diagram. Okay, truth table I can draw. So here if you see so inputs, what are the inputs? y3, y2, y1 and y0, and what are the outputs? a1, a0, and one more output is there, that is valid output. Okay, so here all inputs are 0. Okay, whatever may be the a1 and a0, you are getting valid output equal to what? 0. Okay, valid output equal to 0 means what? So then it is checking for the all inputs are valid or not. Okay, so when all inputs are valid, that means any one of the input is 1, then the valid output becomes 1. Okay, next, so I will come from the lowest level. Suppose y3 is having the highest priority, so y3 becomes what? 1. Whatever may be this y2, y1 and y0, okay, you will get what? 1 1. Okay, it is having valid output, so this is 1. Okay, whatever, don't care, invalid, that means either it may be 0 or 1. So this is having the highest priority, this is having the highest priority, the output becomes what? 1 1. Okay, this logic equivalent, you will get the output. Okay, next, if it is 0, it should be 0, and next y2 should becomes 1, and it can be either, don't care, 0 0, you are getting what? 1, you are getting 1 0. Now you got y2, no, we'll get 1 0. And next, this becomes 0, this becomes 0, and this becomes what? 1. Okay, and this is don't care. So don't care means either 0 or 1. So y1 becomes 1, this is 0 1. Okay, again 0 0 0, and this becomes 1. So here it becomes a 0 0. Okay, so in all cases this is valid output. Okay, the output should be 1, output should be 1. Okay, so from this I can get the truth, means min terms for this a1, a0 and v. So a1, if you see a1, what are the min terms? Where you got this one? So this one and this one, no? So 0 1, don't care, don't care. Okay, and 1, don't care, don't care, don't care. 2 don't cares are nothing but you can write 0 0 0 1 1 0 1 1. Okay, this is 0 1 only, this is 0 1. Okay, this is 4 5 6 and 7, and 3 don't care means 8 possible combination: 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 and 1 1 1. Okay, and this is 1 only, this is 1 only. So here you are getting 8 9 10 11 12 13 14 and 15. Okay, so here a1 equal to what? A1 equal to summation of m of 4 to 15, summation of m of 4 to 15. So if you draw the k map, what you will get? So if you draw the k map, okay, for a1, so k map for a1, k map for a1. Okay, so this is how many variable k map? 4 variable k map I need to draw. So this is y3, y2, y1, y0. Okay, 0 0 0 1 1 0 1 1 0 0 0 1 1 0 1 1. Okay, 0 1 2 3, next 4 5 6 7 8 9 10 11 and 12 13 14 15. Okay, so what are the min terms? 3 4 to 15 you got, no? So 4 to 15 means 4 5 6 7. Okay, 4 5 6 7 a1, no? Okay, 4 5 6 7, and next 8 9 10 11 12 13 14 15. Okay, so this is one octet, no? This is one octet, and this is one octet, this is one octet. Okay, so octet will eliminate 3 variables. If you write for this, this is y3 and this is y2. Okay, so what is my a1? A1 equal to y3 plus y2, y3 plus y2. This is a1, this is my a1. Okay, and next is I need to draw the k map for this a0. Okay, so a0, if you see a0, what are the min terms? So here I am writing the min terms. A0 equal to 0 0 1 don't care. Okay, this one second. this one you will get. Okay, so 0 0 1 don't care, and 1 1 1 don't care. Okay, so anyway 1 don't care you got in this equation, no? Okay, so I got this. Okay, so here you will get for a1, for a1 what you will get, so for a1 a naught, this is for a naught. Okay, a naught equal to 0 0 1 don't care. Okay, so this is anyway 0 1. Okay, 0 0 1 0 0 0 1 1. So 1 this is 1, only 1 is there. Okay, so here this is 2 and this is 3. Okay, and one more is 1 don't care. Okay, you got these values from where to where, 8 to 15 you got. Okay, previously you got, no? So again I am not writing, just previously you can see. So here 1 don't care, you got the values 8 to 15. Okay, so what are the min terms? So I can write a naught equal to what? I can write one second, a naught equal to summation of m of 2 3 and 8 to 15. 8 to 15. So next I need to draw the k map for this a naught. Okay, so k map for a naught, how to draw? Okay, so here you see, so here you see, so what are the inputs? Y3 Y2 Y1 Y naught. Okay, 0 0 0 1 1 0 1 1 0 0 0 1 1 0 1 1. Okay, 0 1 2 3, next 4 5 6 7 8 9 10 11 12 13 14 15. Okay, 14 15. So those midterms you write. Okay, 2 3 2 2 3, and from 8 8 9 10 11 12 13 14 15. Okay, so this is one octet. Okay, this is one octet, and corner grouping is allowed. Okay, this is one quad. From this I will get octet. This is y3, and what is this? This is which is common, y2 bar, y2 bar y1. Okay, y2 bar y1. So what is my a naught? A naught equal to y3 plus y2 bar y1, y2 bar y1. Okay, this is my a naught. Okay, similarly you need to find out for v, okay, so if you observe v, except 0 remaining all are 1, no? Except 0 remaining all are 1. Okay, so from this I can write, so I can write as, see here, so v equal to summation of m of 1 to 15, 1 to 15. So I will draw the truth k map for v, 4 variable k map. So this is 4 variable k map. What are the inputs? y3 y2 y1 y naught. Okay, 0 0 0 1 1 0 1 1 0 0 0 1 1 0 1 1 0 1 2 3, next 4 5 6 7 8 9 10 11, next 12 13 14 15. Okay, so here you see, so except 1 remaining all are 1, no? So 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15. Okay, so from this this is one octet, and this is one octet. Okay, and if you see, this one is one octet, this one also one more octet, this one also one more octet. Okay, so if you see for this one, What is this? This is y3. What is this? Y2. What is this? Which is common y0. What is this? Y1. Okay, so v equal to what you will get? V equal to I can write y3 plus y2 plus y1 plus y0. Okay, so this is v, valid output or not. It is checking for valid input or not. Okay, so from this I can draw the logic diagram. So what you got? So you got the expression for v. Okay, expression for v, a1 and a0. Okay, so what you got? a1 equal to y3 plus y2, y3 plus y2, and a0 equal to what you got? Y3, a0 equal to a0 equal to, one second, y3 plus y2 bar y1, and v equal to y3 plus y2 plus y1 plus y0. Okay, so you can draw the logic diagram. So how to draw this logic diagram? So here this is what it is given through the OR gate. Okay, the inputs are y3 and y2. Okay, so a1 equal to what? Y3 plus y2. Okay, y2, and next y2 is connected with an inverter, and one more input y1 is coming, and these two are connected with an OR AND gate. Okay, so this is y1. Okay, y1, and y3, you take this input. Okay, this input, and this is given to OR gate. Here what you will get? So here you will get y2 bar y1, y2 bar y1. Here a0 equal to what? Y3 plus y2 bar y1. Okay, and similarly you take for this v. Okay, v is nothing but y3. Okay, you take this input y3. Okay, and y2, and next y1. One more input is there. Okay, one more input is y0. Okay, so this is y0. Okay, y0 is connected with the OR gate. This is what v equal to y3 plus y2 plus y1 plus y0. Okay, so like this we can get the encoder. Okay, priority encoder. Okay, so this is about the encoder 2 to 4. So we discussed about what is encoder, 2 to 4 encoder. Okay, 4 to 2 encoder, and octal encoder. Okay, so this octal to binary encoder, and priority encoder. Why we are going for the priority encoder? There are two ambiguities are there. What are those ambiguities? Suppose when all outputs are equal to 0, okay, and all inputs are equal to 0, okay, so encoder can't find out the output, or one or more inputs is active high, then also we can't, it will give the wrong output. Okay, so that's why we are going for the, so in order to overcome that ambiguities, we are going for the priority encoder. So priority encoder, depending on this so three inputs are there depending on the priority. So y3 is having the highest priority and y0 is having the lowest priority. So two inputs are coming or three inputs are coming at a time. So what happens, which is having the highest priority, that will get at the output. And also one more valid output is there. Valid output, it will check for whether the given inputs are valid or not. If given inputs are not valid, it will give the output as 0. If given inputs are valid, then it will give the output as 1. Okay, it is checking for whether the given inputs are valid or not. Okay, so your task is you need to design priority encoder. Okay, priority encoder, that is y0 is having highest priority, then y1 is having the highest priority, y2 is having the highest priority, and y3. This one you need to design and share in the group. Okay, or share me personally after designing. Okay, okay, so this is about encoders. One second.